please. And I don't mean more on equations, I mean more on equations. Don't take that the wrong way. Equations, boys and girls, equations. And the little subheading under this equation is, anybody? Variables on both sides. Variables on both sides. So write down this for example. Let's just pick one that looks really intimidating. How about this one? 5 times 2x. Is there something going on here that's killing my board? 5 times 2x plus 4. I am going to quit. 4 minus 2x equals 6 plus 2 times 3x plus 12. Is that all there is? Yes. Yes, and more yes. Now, ladies and gentlemen, please understand this. This is not a hard thing, but it is somewhat complicated. Here are the steps that you must see here. Step number 1, anytime you're doing equations, okay, is you need to simplify both sides first. Simplify both sides. If I simplify both sides here, what am I going to do here? Use what property to get rid of what? Chase, you seem to be answering much like really good stuff today. What do I have to do here? And which would give me what? 5 times 2x is? 5 times 4 is?
20.
20. And I still have this plus 2x, right? On the other side, what do I get?
It's
6 plus 6x plus 6, 2 times 12 is?
24.
Can I simplify any more? Did I do something wrong?
It's minus.
Wait.
It's minus.
This one is?
Mm-hmm.
So is that what you had, so?
Yeah.
Alright, good. I'm glad you thought that, because that would have been my tragic downfall. Thank you for catching it before I got to the end. Now, can I still simplify each side a little bit more? Yes, I can combine like terms. What can I put together over here?
10x into
10x minus 2x is
the
8x plus 20 equals, what can I put together over here?
6 and 24.
Chase, remind me to give you something. You don't know the Panera thing? Anybody use one of those?
No.
Nobody's even used them?
Not yet.
Mine's sitting out the table.
I'm waiting for Panera.
Oh yeah.
Wait, what?
They might expire by the end. They expire by the end of the year.
That's the present.
Alright, so now, can I simplify each side anymore? I cannot. That leads us to point number 2 here. After you get to that part, you have to, wait, I don't want that. Shoot. Step number 2 is you need to move all x's, move variables to one side and numbers to the other. And numbers to the other by doing their opposites. And it doesn't matter which side you bring the x's to, what side you bring the numbers to, as long as you do different sides. You know, you may want to keep things positive, so in that case, I want to get this 6 over here. How do I get it over the great divide here? I subtract. I subtract. So now I have 2 x's over here. How do I get my 20 over there? Again, do the opposite, and I get 2x equal to 10. And you will find that, generally speaking, the very last thing you do is divide what's in front of the x. Or, in mathematical words, what do we call that number? Remember? We don't use it this year. The coefficient of x. The coefficient of the variable. Which means my answer would be divide by 2, divide by 2, x equals 5. Does that seem, oh, Connor Morgan, does that seem doable? I'm going to give you
Why
one.
do you subtract 20 from 30?
Because to get 20, this 20 to that side of the equation, I have to do the opposite. It was adding 20, so I subtract 20. 20 minus 20 gives me nothing on this side, and I have to do that same thing to that side. Do that help? Ready for your own challenge? This is today's challenge problem. Jesus. Trying to butter enough today. Ready? 10 minus 6x equals negative 2 times 3x minus 5. Go ahead and solve that for x for me, please. Then we will do one more fun and exciting one. Finito? You understand you're multiplying through by a negative 2 over there on the right hand side. Not just a 2, but a negative 2. Which is going to change some bizarre things there. Well, they would not do something of that, did they? Where did this problem end up? Where was this problem? Did I write it down wrong? Oh, jeez. How many people hit a roadblock there? Anybody? Good, because if you do this, and my bad for not looking at the end of this whole problem, you can simplify this, right? But you can simplify this to be negative 6x, what, plus 10? What happens here if you add 6x and move it to the other side, or if you add it to either side, what happens? It goes away, and your 10 then equals 10. If that ever happens, ladies and gentlemen, this is probably good to write in your notes. This is what we call an identity problem. And what that means is x can be anything, or there are infinite solutions. No matter what number you put in for x, you will get a true statement. You with me on that? No matter what you get for x, you will get a true statement. For example, if I put 1 in for x, what's 10 minus 6? 4. If I put 1 in for x, what is 3 minus 5? Negative 2. Negative 2 times negative 2 is 4. So you get all the solutions in the world. I should not have done. I should have given you that one. I apologize. Forgive me. But you will. All right, now look at problem number. This is the one I really want you to look at. Lesson 28, page 167. Let's see if you can use your mathematical skills to answer problem number 3. You have $3 in bills and a certain number of nickels in one pocket. Has that ever happened to anybody? No nickels in one pocket? In the other pocket, you have $2 in bills and a certain number of dimes. You have the same number of dimes as nickels and the same amount of money in each pocket. Write an equation to find the number of dimes and the nickels you have. Oh, Why are we stopping? Andrew, what's your thoughts on that? First of all, what do they say? You have the same amount in each pocket, right? You have the same amount in your left-hand pocket as you have in your right pocket. So the same amount of money, same amount of cash. Well, how much cash? What do I know about this left-hand pocket? I have how much money? For sure. $3, right? Plus what? What do I have with it? Nickels or dimes? Nickels. Right? How much is a nickel worth? We know the value of a nickel, right? So I have $3 plus a nickel, which is worth 5 cents. How many nickels do I have? You don't know. So I'll just put the letter N there, right? I know that equals how much in the other pocket? $2 whole plus what? How much is a dime worth?
10 cents.
10 cents. And here's the beauty of this, children. How many dimes do I have? I don't know. So I should make that Y. Except for one little thing they tell me is that what? I have the same number of nickels as I have dimes, so I can use the same letter for them, which makes your life easy because we haven't solved equations that have two different variables in them yet. So there is your equation. $3 plus 5 cents times every nickel has to equal $2 plus 10 cents times every dime. Then how would I solve that? John, give me a suggestion. What if, John, what if I don't like working with decimals? What could I do? Now, what if I don't like working with fractions either? We talked about this the other day. Somebody, how can I get rid of all my decimals? John? Multiply everything by 100. Multiply everything by 100. What do I get if I multiply 3 times 100? 300. What do I get if I multiply 0.05 times 100? I get 5n. What do I get if I multiply 2 times 100? And what do I get if I multiply 0.10 times 100? 1n. No, just, 10. I'm sorry, it is 10. Sorry. And then based on what we just learned, we can solve this, right? What would I do? I'm going to move my 5n over there because I want to work with positive numbers. Move my 5n over there so I get 5n, which means I need to do what with this? Move it to the other side. 300 minus 200 is 100, and if 5 times what number is 100? Anybody? And equals 20. What is 20? 20 is how many what? And dimes I have. Does it work? If you have 20 nickels, how much is that? $1. So I have $4 in this pocket. If I have 20 dimes, that's how much? $2. So $2 plus $2 is $4 in that pocket. Sometimes people crack after that. It's too late to appreciate. Oh, it is too late. All right, for tomorrow, let's give some of these a shot here. I would like for you to do anything. We're going to try this. Anything that has a wow, look at all these. I was going to say 27 or 28. There doesn't look to be very many of those. Let's do that. Let's do 21 through 30. Lesson 28. 21 through